In the scenario of a file curving and I need some information about files. Actually, files are data, which means series of numbers, and different file types interpret what they what do they mean. Data usually are in binary, which means a choice between two alternatives, which is ones and zeros. And typically, we see files as hexadecimal values, which has values from 0 to 15. Now, I'm gonna do a challenge to know what is the type of file. I mean, um, because a file extension is JPEG or JPG, it doesn't mean that it's JPEG extension. It doesn't mean that it's a file type of JPEG. Maybe it can be JPEG or JPG, and we see it as JPG, but it's a PNG file, or vice versa. And at the beginning of every file, there is a binary values which indicates what file type the file is. This signature is used to determine the file type. However, you would change the extension of that. And it's usually published by the creator of the creator of the file to know about their actual protocol, whether it's hexadecimal or decimal. Now I'm going to do this challenge with a file, JPG file or PNG. We're gonna see that with a command line. To do this, I'm gonna open a terminal. Now, I want to know what's the file type is in this scenario. So I'm using file command. First, I need to be in the in the location that where my file is exactly is. So then I choose file command to see my file type project. This is a PNG file, so we got that this file is a PNG, and these are dimensions and metadata of a file that this command gives us. Now I'm gonna move the file type to a JPG file with mv command. Now, as you see, the file type has changed to JPG. Did it really change? Now we can use the file command to see. Oh, sorry. We should enter the exact name of the file. As you see, the file extension now is JPG, but the actual file type in this scenario is PNG. So first, looking at the file, you you cannot distinguish that it's a PNG file. And now I'm using a command XXD to see my file. XXD command puts our files in columns and rows and convert the data into a printable character using ASCII tables. So in this scenario, I'm putting this command to see the first 10 lines of my file. Now, as you see, we can see the values of my file with XXD command. As you see, it's my file type is PNG, and these are line offset, which is artificial and is produced by XXD command. And these are file hexadecimal values, which is raw data, and these are attempts by the XXD to convert the file contents into a printable characters. Each set of 2 hexadecimal is a byte, which a byte has 8 bits. Data is a string, and there is no segment on actual data itself. This is the XXD options, which puts files in rows and columns like this. Now, if we Google ASCII table, we can see how these numbers correspond to our files. Here we have ASCII tables. In this command, in this file table, we see 89, and if we take a look at ASCII table, it ends to 7F. So we do not have 89 in ASCII table. So 89 corresponds to a dot, and then we have 50 in ASCII table. If we look at a hexadecimal values here, 50 corresponds to uppercase P. So we can see uppercase P here, and so forth. And the rest of the data, which is here, is just the interpretation of data in the file. It's not how the files should be read. These file types and file signatures, which is here, it's just for a convenience. And if we search the list of file signatures, magic bytes, if you Google Wikipedia magic bytes, you can see list of file signatures, and how the numbers, the hexadecimal values, hexasignatures interpret the file types. And as you see here, the file, how these hexadecimal values interpret file extensions, and they are just for the interpretation of our file type, the extensions. And this is the way XXD command gives us the information, and they can be different in other types and scenarios.